This is the worst example, I'm not gonna lie. This one is where students get tripped up the most, so please feel free to pause, rewind, ask questions, watch it again, whatever it takes. This one says a square has a diagonal of 25 centimeters. What that means is, here's our square, and the cool thing about squares is that all sides are equal and all corners are 90 degrees. So all of these are 90 degrees. What we know is the diagonal is 25 centimeters. So this is 25 centimeters. Now you may notice we have established a nice little right triangle here. So we have a right triangle with the hypotenuse being 25. Now normally we would call this A and B. So we'd have A squared plus B squared equals C squared. But these two sides are the same. Why would we call one thing two different names? That's silly. So instead what we do is we choose either A or B. I'm going to choose A. Instead of calling this side B, I'm also going to call it A because again, they are equal. So our normal formula says a squared plus b squared equals c squared. We know we're going to need to use the Pythagorean theorem because it wants us to find the sides, and all we know is a hypotenuse of a right triangle. Now here's the tricky part. A squared is a squared. And b squared is actually this red a squared. And that's equal to 25 squared. So again, this is here, this is here. That is right there. So let's simplify. If you have two of the exact same thing, a squared and a squared, hopefully you agree that we have two a squareds. And that's equal to 25 squared, and 25 squared is 625. Now we still have to do the same thing, which is simplify and solve. So to solve, we would divide by 2 on both sides. These chunga chunga, we get a squared equals 312.5, and then you square root both sides. A is 17.68 if we round. So its sides are 17.68, 17.68, 17.68, and 17.68. Second thing we have to do is find the perimeter. So the shortcut to do this, since it's 17.68, 17, 17, 17, is to do 4 times 17.68. If you want to, you could do 17.68 plus 17.68 plus 17.68 plus 17.68. But even saying it is exhausting. So I'm going to do 17.68 times 4, and I get 70.72 centimeters. I should label this because this one has labels on it. And then last is area, and for a square, it's base times height. So our base is 17.68. Our height is also 17.68. So if we do 17.68 times 17.68, we get 312.58 centimeters squared. Now, some of you might recognize this as being very similar to this number here, and that's because base times height is a times a, which is a squared. So again, base times height is like a times a, which is a squared. That's this value right here. So our answer should end up being similar. Please don't panic. I'm just making a connection in case you noticed. And then last is a picture problem. So this says a ladder, a 20-foot ladder leans against a building. So here's our building, and here's a ladder. The bottom of the ladder is 5 feet. Sorry about that. The bottom of the ladder is 5 feet from the base of the wall. How high up the wall will the ladder reach? So they want to know how high will it go. If the ladder is 20 feet and this distance is 5 feet. We've got a triangle here because the building needs to have 90 degrees with the ground. So we've got 5, 20, and we'll just call that A. So right triangle, we need to find a side, so we'll use the Pythagorean Theorem. A squared plus 5 squared equals 20 squared. This is 25 and 400. Oops. We need a minus 25 on both sides. A squared is 375. And then square root both sides. We get 19.36. So it would reach, 19.36 feet up the wall.